66. Signs of fractions. Okay. Just a quick review. If I have a fraction and I have a sign that's negative, this is exactly the same as, what's the difference?
It's just that's in the middle and
It's in the middle. This is a discussion we've had with Q-Hole.
Yeah, it's
So not with everybody. Okay. So what's the difference between all these? In the end, it's exactly the same. I have one minus sign. The minus sign means I am multiplying this, whether it's here, here, or here, times minus 1, right? That's what it means. So the fact that it's in the top, in the middle, or in the bottom doesn't really make a difference. It's the same thing. They're all being multiplied times minus 1. Is that okay? Is that clear? If I've got 3/4, this is positive, correct? If I've got this is going to be the same as this. Why?
because minus times minus equals
It's positive, yeah.
Because this is the same as having 3/4 times minus 1 times minus 1 in the end, right? And this is plus. Okay? Is that part clear? Yes? Very clear? So why am I going through this again? Because if I have a minus here, is this what you're doing? Good. If I have a minus here and I have x plus 3 over x, this can either be, this minus is in the middle, look. This can either be x plus 3 over minus x, or it can be minus x minus 3 over x. Ooh, weird. Why minus x minus 3?
because you're multiplying it on
Because I multiply it here. Even though there's no parentheses, I'm going to put it so that you know that this minus affects everybody at the top, not just the minus x. Is that clear? Right. Completely clear. Because now we're going to apply this. Yes, Cubo?
Now I'm wondering why it's applied to everything except for one minus sign.
Because it's in the middle. It's here. So this is, if it's here, it means I am multiplying minus 1 times x plus 3.
But didn't you say before that in the middle it's gonna be the same thing as minus 3 or
Exactly.
Yeah.
So if I put it here, it's for everybody. Because all of this is in the top, not just the not just the x. Okay, so this minus gets distributed with everybody. That is what I'm teaching you today. It is not just the x, it's for everyone. Okay? So, how are we going to apply this? Well, let's say I have this. 1 x minus 3 minus 7a over minus x plus 3. Okay. First of all, fractions. Ooh, fractions. We don't like fractions. Why not? I don't know. So, first things first. If I am, it says subtracting fractions. We go back to when we learned negative numbers, and you remember that subtraction is the same as
Addition.
subtracting.
addition.
It is. No, subtracting is the same as adding.
I told you.
No, adding the opposite.
The opposite. Very good. The opposite are the inverse, right?
Well,
The opposite of a number. Do you remember this?
mhm.
Okay. So in other words, this is the same as adding the opposite of either of these two, correct? Now, what's the other thing I need when I am adding or subtracting fractions? What do I need to have? The same denominator. Do I have the same denominator? Not exactly. They're similar because they both have x and 3, but the signs are different. Yeah. How can I make this sign the same?
Multiply times
So I'm going to change this into, instead of putting the minus here in the middle, I'm going to pass it to the bottom. But if I pass it, that means I have to leave something there. I can't just move it. So I'm going to take that rule, and it's the same as adding the inverse. So I'm going to have the 7a, because remember that it didn't matter if I put it in the top or the bottom?
Over x plus 3.
So I'm going to have minus x plus 3. See what I did? All I did was move the minus to the bottom.
Yeah.
Because we can have it anywhere, right? And that gives me 1 over x minus 3
Plus
Plus
7a
7a.
over x minus 3.
x minus 3. Ah, wonderful. I now have the same denominator, and I have 1 plus 7a. Okay. Hey, don't clap yet. Okay. Is this clear?
Yeah.
Yes?
Is that part of the...
I am going to erase because I'm going to go a little farther now. Do you want to follow me over there so I don't erase?
No.
You don't want to move that thing?
I could,
erase?
but I don't know if you guys want to move, like.
Okay.
Okay. So I'm moving. I'm moving.
Ooh, yes you
I'm
are.
moving. I am moving. I am moving. 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 Move.
Oi, I'm a failure as a cameraman.
As long as it's not fast because it makes everybody puke. I get really, really nauseated when.
Do you watch the videos though?
Huh?
Do you watch the videos?
No. Never. But I've seen my brother do movies, so I kind of have an idea. Okay. Make movies. What do you do when you have this?
Do movies.
2x minus 3, 3 minus x. Okay. Same problem. Damn. They look almost the same except for that sign.
It just seemed.
Whatever shall I do?
Miss it.
I don't know what's close.
What do we do? What do we do? Well, yes.
Do we?
No, we don't switch anything because we can only change things that'll leave it exactly the same. So, what if I change that plus?
Minus.
How can I change it to
Minus.
I can change this into minus over minus, right? Does everybody agree? So let's do that. So I have 4x plus 5, x minus 3, because all I need here is a minus, right? To have it the same. So I'm going to put the minus, the one on the top that I'm changing, I'm going to put it in the middle. And it affects everyone. So please put that in parentheses. Is that clear?
Yes.
And the bottom,
X negative
The
x
minus,
plus 3.
and I have 3 minus x. I'm going to do step by step just so that nobody gets lost. Do you agree that this and this is exactly the same thing? Yes? Sit up before you fall asleep. Okay, so we've got 4x plus 5, x minus 3, minus 2x minus 3, over x minus 3. Yay! Same denominator. So now I put this in the same denominator. Why did I put the parentheses? So that when I put everything in the top, I don't forget that that minus is for everyone, not just the 2x. It is the most common mistake everybody makes, is not to put the parentheses and then just put the minus on the 2 and not on the 3. So I've got 4x plus 5 minus 2x minus 3, all of it.
You just get it.
4x plus 5 minus 2x plus 3. And now I can simplify. This would be 2x plus 8 over x minus 3.
No.
Is that clear?
Yeah.
What I did and how I did it? Okay, don't clap yet.
It's for you, Ian.
Are we done here?
Yes.
Okay, we're moving. We're moving. We are moving. We're moving. Ouch! We're moving.
Andrea,
We're moving. She's so sweet, isn't she?
You know, right?
How?
A little bit.
Yeah. I know. I'm a cameraman. I
She's
get
so
the
nice.
perfect angles now.
Who knew? She
Me?
could be so sweet.
Oh, I'm so sweet.
When you want it, otherwise it's Andrea, quítate. Andrea. Okay. Completely different
Oh
topic.
my god.
I think that's
Just looks bad, it's easy. Second topic. 30, 60, 90 triangles. Okay, so far, we've seen that there are something called reference triangles. That they are always going to behave the same exact way. The one we've seen already is
I saw
the 45-degree one. Remember? We saw it? Have we seen it? I think we have.
Yes,
No.
we have, but can you repeat it, please?
I am right now. 1, if it's 45, do you remember the rule that says, or the property that says that if angles are the same, the sides opposite those angles have to be the same?
Yes.
So, 1 and 1, right?
Mhm.
Because they have to be the same. And this one happens to be square root of 2. Because the square root of 1 squared plus 1 squared is 2. Square root gives you the hypotenuse because of Pythagoras, right? So, what happens with a 90, with a 60, 30,
And 90.
90 triangle? Well, whatever is shortest, the smallest angle has to have the shortest side on the other side, right?
Mhm.
Because it's not open so much. So, whatever has a 30, opposite it, a 1. Okay? The hypotenuse is 2, and the rest is square root of 3. Got that?
No.
No what?
I didn't get it.
What don't you get exactly?
The 2 and the square root of 3.
Okay. These are called unit triangles because there's always going to be a 1 somewhere. So we know that whatever's opposite the 30 has to be the shortest. So it's got to be the 1. I'm telling you, this was a 2. So if you have 2 equals 1 squared plus this one, which we don't know, let's call it
X squared.
b squared.
2 is also squared. 2 would be squared.
2 would be squared. So this is 4 minus 1 squared. So far so good?
4 minus 1.
I'm just going to put a 1. 4 minus 1 equals b squared. 3 equals b squared.
Square root of 3.
Square root of 3
Yeah.
equals b. So I can easily say square root of 3.
Yeah.
Okay? The good thing is that you don't have to do this.
Yeah.
All you have to do is know that whatever's opposite the 30 is a 1, the hypotenuse is the 2, and the other one's the square root of 3. 1, 2, 3.
Always,
Okay.
miss? Always?
Always.
Always.
Just like this one is always 1, 1, square root of 2. Okay, now, why do I have these reference triangles? Well, these triangles are used everywhere when it comes to building stuff.
No, don't take those off.
No, I'm just going to show you something cool. In fact, when you make blueprints,
What?
you know what blueprints are?
To make like
Yeah.
to build
To build stuff. Planners. Where the designs are.
Why is it blue though?
They are either done with 45, and those are called military style, and they look something like this. It would look, I'll show you what the difference is.
Like a badge.
No. If I make a cube in this style, it's going to look like this. Like a cubert thing. Okay? That's my cube in military style, and this is going to be 45, and this is going to be 45. But if I do it in that one, it's going to look like this. Where
Three-dimensional.
this will be 30, and this will be 60. See the difference in styles? So you use these triangles in more than just finding out angles, and in more than just finding. So look at these. I don't know if you've ever noticed, if you've ever gone with your mom to buy these things, and they always come in a set.
Yeah.
And the set is always, it always has the ruler and 2 triangles. You're like, what's the difference? Right? Triangles are triangles, but they're not. This one is 30-60. See? 30-60. And this one is 45-45. They don't even fit, because I don't know if you've tried these, but I was a weird kid, and I would always kind of like, it's not the same, because the angles are not the same. What you do with these, have you seen a T ruler? It has a T, like a top, and kids always are carrying around with a drawing board.
Yeah.
The T rulers are used with these triangles to make 60-degree, this is 45-degree lines, or 60-degree lines, 60-degree lines or 30-degree lines. That's what they're used for, and that's why these are straight. That's for technical drawing. We're not going to do technical. This is just a little bit of trivia here. What's up, Mr. Lowe?
It's like kind of random, but why are blueprints blue?
That's a good question, actually. Blueprints are blue because back in the day, they would poke holes, and they had this paper that was that reacted to acid that you poured through the little holes before photocopiers and before when you had to do them in hand. So they would grab the original the original not blueprint, the original design. They would poke little holes through it, and then they would place it on top of this kind of like litmus paper. Well, it's not litmus paper, that type. And it would react to the acid that they would pour on top of the other one, so that it would react and it would turn blue. That's why. And now they're called blueprints, even though they are black, right? Black and white. But that's, yeah, I actually asked that the same question myself. Okay, so
Yes.
what are you going to use this, now that you understood that math goes beyond just the numbers, what are you going to do with this? They're going to give you a triangle, like this. Just by looking at that, we know it's a 60, but they give it to you, x and y. And they want you to find x and y. So, and they tell you, use similar triangles. Where's a similar triangle? Ah, right here. 60, 30. What did we say goes against the 30 always? The 1, the 2, square root of 3. And this one has to be. Now you've got 2. So,
we just have to
5 is to 2 as x is to square root of 3. And you can find the x. 5 is to 2 as y is to 1. You can find the y. It's that simple. And that's it.
Does it tell they said 30-degree in the?
You have to put it. No, you have to put it in the same exact position. First of all, if this is 60 and this is 90, that's 150 right there.
Yeah,
So it has to be.
yeah,
30.
for 1.
By definition. And if you, without even adding up, you know that if this is 90 and this is 60, the other one has to be 30.
Yeah.
Okay?
Then we find y, like 5 squared equals x
X
squared
would
plus y
equal
squared.
5 square root of 3 over 2. And y would equal 5 over 2. Okay? Okay, don't clap. Are we clear?
Yes.
Peace.